Introduction to Geometric Sequence. Hello, everyone. We're going to look into geometric sequences. So a geometric sequence is a sequence of numbers where each term after the first is found by multiplying the previous term by a constant. And this constant is called the common ratio, denoted by the letter R. It is important to understand geometric sequences as they are used to model exponential growth and decay, and which are common in various real-world scenarios. General form of a geometric sequence. A geometric sequence can be written in the following way: AR squared, AR cubed, and so on. Here, A is the first term of the sequence, and R is the common ratio. And each term after the first is obtained by multiplying the previous term by the common ratio R. So if you're to use Python, we could have function called geometric sequence, which takes the first term A, the common ratio R, and the number of terms N as inputs, and it generates a geometric sequence using a list comprehension. And once we have this function, we can use this by providing the value of A, R, and N. So for this example, it generates the first 5 terms starting from 2 with a common ratio of R, 3. And we would have the output to be 2, 6, 18, 54, 120, 162. Examples of geometric sequences. So if you're to take a look at some examples of geometric sequences, we'll look at 2 examples. First, let's consider the sequence 2, 6, 18, 54, and so on. In this sequence, the first term A is 2, and the common ratio R is 3. You can see that each term is obtained by multiplying the previous term by 3. Here's another example. We have the sequence 100, 50, 25, 12.5, and so on. Here, the first term is 100, and the common ratio R is 0.5. So each term is obtained by multiplying the previous term by 0.5. And we can use the geometric sequence function that we defined in the previous slide and provide appropriate value of A, R, and N as an input. Finding the nth term. In order to find any term in a geometric sequence, you can use the formula of the nth term, which is A times R to the n minus 1 power. So if we take a look at an example, suppose we have the sequence 5, 10, 20, 40, and so on, and we're interested in finding the 6th term. So the first term here is 5, and the common ratio R is 2. And in order to find the 6th term, we can use the formula and provide 5 and 2 and 6 for A and R and N. And we should have sixth term as 160. And in Python, we can create the function nth term, which calculates the nth term of a geometric sequence. And we use the nth term formula. And then we can provide a value of A, R, N. Sum of the first n terms. The sum of the first n terms of a geometric sequence is given by the formula here. A times 1 minus r to the nth power divided by 1 minus r, where r shouldn't equal 1. So if we take a look at an example with the sequence 3, 6, 12, 24, and so on, we are interested in finding the sum of the first 5 terms. Here, we know that first term A is 3, common ratio R is 2, and we would substitute into this formula, then we should get 93. And here, Python, we have the function sum of n terms, which calculates the sum of the first n terms using the formula. Then we should be able to provide appropriate A, R, N in order to calculate. Applications of geometric sequences. So in finance, they are used to calculate compound interest, where the amount of interest grows exponentially over time. And they are also useful in determining the future value of investments and loans. In population studies, geometric sequences help model population growth or decay, where the population size changes exponentially over time. In physics and engineering, geometric sequences are used to model processes that involve exponential growth or decay, such as radioactive decay and sound intensity. And in computer science, geometric sequences can be used to analyze algorithms that have exponential time and complexity. And here is an example that geometric sequence example that models compound interest. Say the principal amount is 1,000 and it grows by 5% annually over 5 years, then we can define principal to be A, annual rate to be R, and years to be N, and provide that as an input for geometric sequence function. We have some practice problems. Practice problem 1, find the 10th term of the geometric sequence 2, 4, 8, 16. And in order to solve this, you want to first identify the first term and the common ratio, and then use the formula for the nth term of a geometric sequence, which is A times R to the n minus 1th power. Practice problem 2, calculate the sum of the first 6 terms of the sequence 1, 3, 9, 27. Here, similarly, you want to identify the first term A, which is 1, common ratio R, which is 3, and number of terms, which is 6. Then we just need to use the formula for the sum of the first n terms. Practice problem 3. Given the sequence 81, 27, 9, 3, find the common ratio and the eighth term. We know that first term is 81, and the common ratio can be calculated by dividing the term with the previous term, which is 1/3, and then we can use the formula for the nth term. Then we can just substitute. Practice problem 4. Determine the sum of the first 4 terms of the geometric sequence 5, 15, 45, 135. Here, similarly, you want to identify the first term A, common ratio R, and the number of terms N. And first term A is 5, common ratio is 3, a number of term is 4. So we can use the formula for the sum of the first n terms, which is 8 times 1 minus r to the nth power divided by 1 minus r. Then we should be able to calculate. In conclusion, geometric sequences are a fundamental concept in mathematics. They are useful if you're doing any modeling work or solving problems that involves exponential growth and decay. In order to, it's important to understand basic properties of geometric sequences, such as the common ratio and how to find the nth term or the sum of the first n terms. And with this knowledge, you can apply to real-world scenarios such as finance, population studies, physics, engineering, and computer science. Thank you everyone for listening.